Welcome back to my YouTube channel. Our topic for today is kinematics. Kinematics. In some books, it's been written as well particles in motion. So either kinematics or particles in motion, they're all talking about the same topic. They are talking about the same topic: kinematics or particles in motion. Okay, so we are starting now. What is motion? Yes. What is motion? Motion is defined as any physical movement or change in position or place. Yes. So another word for motion is what? Movement. Another word for motion is movement. That's why motion is defined as what? Any physical movement or change in position or what? Or a place. Yes. So I'm holding this one. If I throw it, motion what has taken place because it will move. I'm standing here. If I move, it means what? Motion what has taken place. So motion is talking about what? Movement. Motion is talking about what? Movement. That's why you define motion as any physical what? Movement or change in position or what? Or place. So that's the definition for motion. That's the definition for motion. So the motion of a car, the motion, any moving object, it means motion is taking place. When an object was moving, it means motion is taking place. Okay, so that's the definition for motion. Okay, so now kinematics. Kinematics is the study of the motion of a particle. Kinematics is the study of what? Of motion of a particle. Okay, so it means kinematics is the parent one, and what? And motion is the what? Is the baby. And because kinematics is the state of what? Motion. Yes, kinematics is the state of what? Motion. Okay, thank you. Okay, so kinematics is the state of what? Motion of a particle. For kinematics, you are studying the motion of what? Of a particle. Okay. Now, let's come to the types of motion. The types of motion. Or the type of what? Movement. Yes, types of motion. Okay. And as you know, motion is what? Movement. So types of what? Movement or motion as well. Okay. So the first one is rectilinear motion. Rectilinear motion. So you can even see it from the word. We're able to get rectilinear motion from the word line, right? Rectilinear motion from the word line. Okay, so what is rectilinear motion? This is a type of motion which takes place along a straight line. Yes, so rectilinear motion is a type of motion which takes place along a straight line. Along a straight line. So if I'm moving along a straight line, it means that type of movement or that type of what? Motion is termed as what? Rectilinear what? Motion. Okay. It is also known as translational or linear motion. Yes. So another word for rectilinear motion is translational motion or what? Linear motion. So if I ask you what is translational motion, it means I'm asking what's rectilinear motion, the same thing. So you give me the same definition for that of what? Rectilinear motion. Okay. Now, example of rectilinear motion. So running a 100 meters race. Running a 100 meters race. Yes, you can see that for the 100 meters race, one person will stand at where the pole is, then run in a straight line to the other end where the other pole is as well. So that's what 100 meters was race. So that's on that part we are taking what? You run through what? A straight what? Line, right? Through what? A straight line. Through a straight line. So running a 100 meters race is what? You are running in what? In a straight line, 100 meters race. So that's the example of what? Rectilinear motion. What other example of rectilinear motion can you also give? Other example of rectilinear motion can you also give? a car moving what? Moving what? On a straight road. Sometimes the car will move what? On a straight road. So that one too is an example of a rectilinear motion. The car moving on a straight road is what? An example of a rectilinear motion. So you have a lot of examples of what? Rectilinear motion. I think for the assignment, I'll ask questions about that. Yeah, so that's all about rectilinear motion, a type of motion that occurs when a body moves in what? In a straight line. Okay, now let's come to the second type of motion. Yes, the second type of motion. Circular motion. So the second type of motion is what? Circular motion. So that one too is being derived from the word circle. Being derived from the word what? Circle. Now, what are circular motion? This is the motion of a body traveling in a circle. Yes. So it's a motion of a body traveling what? In a circle. Motion of a body traveling in what? In a circle. So whilst a body is traveling in a circle, circular form, that movement or that motion is termed as what? Circular motion. So now, what are some of the examples of circular motion? Examples of circular motion. Satellites moving around a planet. Yes. So you know that the satellite moves around what? A planet. So let's take the Earth as a planet, right? So the satellite moves around what? Around the planet, being the what? The Earth. Yes. So satellites moving around the planet is termed as what? Circular what? Motion. So when satellites are moving around the planet, it's termed as what? Circular motion. Then we have a motorist negotiating a curve. You can see nowadays we have a lot of what? Motors around. Yes. When they are negotiating the curve, it is termed as what? Circular motion. When something like that. Yeah. To negotiate what? A curve. When someone dies, you can see them. Sometimes they even use car to do that. For this intermittent that they do. Yes. They usually negotiate what? A curve. A curve like this. Yes. That's what an example of what? Circular what? Motion. A motorist negotiating what? A curve. Okay, the other example as well. The planet revolving around the sun. You know that the planet moves around the sun. So when the planets are moving around the sun, that one too is an example of what? Of circular motion. That one too is an example of circular motion. Okay. Now we are done with circular motion. Yes, so simple. A circular motion when the body travels in a circle. Okay. Then these are the examples of it. Okay, now let's continue. The third type of motion or movement is spine or rotational motion. Spine or rotational motion. What is rotational motion? This is the type of motion in which an object rotates on its own axis. Yes, so it's a type of motion in which an object rotates on its own axis. When you go to where they barber the head, right? Yes, where they barber your head. That's barbering salon. Yes, barbering salon. You can see that the chair that you sit on, you can turn around. You can turn around. But whilst you are turning around, that chair moves on its own what? Axis. That is spine or rotational motion. That is spine or rotational motion. So spine or rotational motion is a type of motion in which the object rotates on its own axis. Right? Okay. Now, example of what? Spine or rotational motion is the rotation of the base of a fan. Rotation of the base of a fan. Yes. So we can see that the fan will also rotate on its own what? Axis. The fan, when you switch it on, it will what? Rotating. But while it is rotating, it rotates on its own what? Axis. It rotates on its own what? Axis. It rotates on its own axis. So that's one example of a rotational motion. Then other example of rotational motion is what? the rotation of a wheel about its axis. The rotation of a wheel about its axis. You can see the wheel also moves or rotates on its own what axis. It moves on its own what axis. It's like the Bible Salon chair moves on its own what axis. We have a certain span. Yes, that helps the body to what rotate on that what axis. How can I get it? Yes. So these are some of the examples of what of the spine or rotational motion. So now we can examine that there's far difference between circular motion and what rotational motion. So if they ask you what are circular motion, don't mistakenly write that of what rotational motion. Because circular motion, for them, they travel what in a circle or in a circular what form. But for the rotational motion, that's when the body travels what on its own what axis. The body travels on its own axis, or the body moves on its own what axis. So there's difference between circular motion and rotational motion. Okay. Now the fourth type of motion is oscillatory motion. Yes, oscillatory motion. What is oscillatory motion? So this is to and fro motion of a particle. To and fro motion of a particle. To and fro. What is to and fro? It means it goes and comes back. To and fro. To and fro. It moves and what? And comes back. That's what to and fro motion of a particle. To and fro motion of a particle. So example. The motion of a simple pendulum. Yes, the motion of a simple pendulum. If you go to the physics lab, you have the simple pendulum set up there. Consider if you hold the metal ball, you throw it like this, it will go and come back, right? Yes, it will go and come back. The thing is the setup is like that, something like that. Yes. So I think this is a metal ball. So if you throw the metal ball like this, it will go and come back, right? Yes. So that's what simple pendulum. So the motion of simple pendulum also is an example of what oscillatory motion, to and fro motion of a particle. Okay. Now the B, the motion of a car's wiper. The motion of a car's wiper is also an example of what an oscillatory motion. Car's wiper. What's a car's wiper? If you can see that you have two plastic in front of the car. Yes, that's car's wiper. So when it is raining, it's moving to and fro, to create a place for the driver to see the road code. On the road code, create the light. Yes. So that's car's wiper. Car's wiper. So while the car is moving, during what? Rainfall, or when it's raining, while the car is moving, the car's wiper moving to and fro to create a place for the driver to see. Right? Yes. So that one too is an example of what oscillatory motion is. An example of oscillatory motion. Okay. So now it's left with the fifth type of motion. Okay. Thank you. Yes. So now the other type of what of motion is known as random motion. It's known as what random motion. What is random motion? This is non-directed type of what motion. Non-directed type of motion. So it means for the random motion, the body what moves haphazardly. Yes, it moves haphazardly. It means it doesn't know where it is going. Right? Yes. So example is the motion of a drunken man staggering about. The motion of a drunken man staggering about. You can see a drunken man. When that person is moving, you can say it's moving like this. That man doesn't know where it is going. That's random motion. It will pass here, come here, pass here, move in front. Random motion. The man doesn't know where he is going. The man doesn't know where he is going. So random motion is a type of motion that a body moves in what non-directed way. Or that the body moves in haphazardly way. Yes. So example is what the motion of a drunken man staggering about. Other example is what the motion of a gas particle. The motion of a gas particle. Yes, they are all examples of what? Random motion. They move randomly. Or even if you can say that maybe the fish, if you put fish in a bowl or something like that, you can say the fish will what? Move what? Randomly. The fish doesn't know where it is going. So that's about what? Random what? Motion. It moves haphazardly or in an undirected type. That fish doesn't know the direction it is what? It is going. That's what? Random what? Motion. Okay, so we come to the end of what? Today's lesson. So we talk about the definition for motion, the definition for kinematics, and the types of motion. We talk about rectilinear motion, circular motion, oscillatory motion, rotational or spine motion, and the random motion. We define them, and we also gave an example of what each type of motion. So I will post the assignments on the WhatsApp platform so that you can do it concerning today's lesson. I hope you enjoy the lesson. See you there other time. Bye bye.